Hey guys, welcome back to the programming interview series where we will be breaking down interview programming questions step by step. For this series, we will be working on a website called Codility, which has lots of free practice questions to choose from. The question that we'll be working on today is Lesson 2, Question 2, Odd Occurrences in an Array. So let's start by reading the question. A non-empty array A consisting of n integers is given. The array contains an odd number of elements, and each element of the array can be paired with another element that has the same value, except for one element that is left unpaired. For example, in array A such that A0 equals 9, A1 equals 3, A2 equals 9, A3 equals 3, A4 equals 9, A5 equals 7, and A6 equals 9. The elements at indexes 0 and 2 have value of 9. The elements at indexes 1 and 3 have a value of 3. The elements at indexes 4 and 6 have a value of 9. And the element at index 5 has a value of 7 and is unpaired. So we could see that 7 is the only number that doesn't have a pair. So for this question, we have to write a function class solution that takes an integer array A as a parameter. So that given an array A consisting of n integers fulfilling the above conditions, returns the value of the unpaired element. So for example, given array A such that the following, so the same as above, the function should return 7 because it's the only number that doesn't have a pair in the array. So what we have to do is we write an efficient algorithm for the following assumptions. So n is an odd integer within the range 1 to a million. So n is the number of elements in the array, so it always has to be an odd number. Each element of array A is an integer within the range 1 to 1 billion. And all but one of the values in A occur an even number of times. So basically, there's only going to be one number that isn't paired up. All other numbers will be paired up. Okay, so we opened up our Eclipse IDE, and we're going to start working on the project here. So we're going to start with our public static int solution, taking integer array A as a parameter. And so we're just going to write out some comments here to see what we have to do. So to start with, if the element is paired, there will be an even number of them. And if the element is not paired, there will be an odd number of them. So basically just like analyzing the problem here. So for every element in the array, if there's a pair of them, so if there's a pair of 9s, that automatically means that it's going to be an even number. And if the number is not paired, that means it has to be odd. So to solve this problem, we will be using a Java map for this. So basically how a map works, a map has a key and a value. So the key is the actual number that we are keeping track of, and the value is the number of occurrences of this number. So to declare this, we do map integer comma integer. So we're going to need two integers. The name is going to be integer bag equals new hash map integer integer with close parentheses. So now that we declared our bag or our map, they're kind of interchangeable in Java, the names of them. So what we're going to want to do is we want to add all of the elements from array A into our bag. So we start with a for loop. We're going to loop through all elements of A. So for integer I equals 0, while I is less than A dot length, I plus plus. And then from here, so when you enter an element into the integer bag, we also need to keep track of how many elements are in it. So we're going to declare integer count equals integer bag dot contains key a at index I. So basically we check if the bag already contains the number that we're entering. So this is a conditional statement. So with the question mark, it declares that it's a conditional statement. So if this is true, then we want to do integer bag dot get a at index I. So this is going to give us the count of the elements. And if it's not true, then it's 0. So if the condition is not true, that means the bag doesn't contain the element. So therefore the count is 0. And then we want to do integer bag dot put a at index I comma count plus 1. So we want to put the number in, and we also want to add a count for how many of this number are in the bag. So as we mentioned, we're using a conditional operator here. So that is just basically using the question mark. And what this is, it's a shorthand for like an if statement. So it's a shorthand for if the integer bag contains a number. So if it contains a number, then we want the count to equal the value at the key pair. So it already keeps track of the value. So we just want to get the value. And if it doesn't contain the number, then we want the count to be 0 because this item was not in the bag already. So with that for statement above, we actually added all of the elements from the array A into the bag. So now that all elements are in the bag, we have to determine which element does not have a pair. So let's start by declaring integer answer equals 0. So answer will be the element that does not have a pair. And now we have to kind of loop through our entire bag, and we're going to check the values for them. So remember that if the value is the number of occurrences of a number in the bag. So remember that if a value has a pair, it will be an even number, and if it is not paired, it will be an odd number. So we will loop through all entries in the integer bag. So a for loop, entry, integer, entry. So for all elements in integer bag dot entry set. So entry set is basically just a set for the integer bag of all entries that were added to the bag. So this is a quick way to loop through every element in a bag in Java. So with the for loop setup, we can start actually performing the calculations here. So we have integer value equals entry dot get value. So remember that the value is the count of the number of occurrences of an entry, right? So if the value modulo 2 equals 1, then the value is odd. So modulo is the remainder operand. So modulo 2 just basically says if you're divided by 2 and you end up with a remainder of 1, then it's odd. So if it's odd, we want our answer to equal entry.getKey, and then we want to break. So the get key, remember the key is the number that we entered. So the answer will be the number. And then we want to break the loop, and we want to finally return answer. And that'll be the end of our solution. So with that, we could start testing our code here on Eclipse. So we're going to start by initializing an array. So integer array equals new integer array. And we'll declare some numbers here, 1, 2, 3, 1, 2, 3, and 4. And so now to test it out, we do system.out.print solution with our array that we just declared, and we'll run it. And we should get, perfect. We got a 4. So 4 is a number that's not paired in our array. So we see 1, 2, 3, 1, 2, 3, and we have a 4 at the end. So clearly the 4 doesn't have a pair. Now if we add some numbers though, so adding in a bunch of numbers here, keeping in mind the pairs, we should see that 9 is the number that's not paired. And so if we add in an extra 9 and let's say remove a 5, it should be 5. Yeah, perfect. So 5 is not paired. Okay, so now that we have tested our program in Eclipse here, we're going to copy it over into the Codility website and see if it actually works and we get 100%. So let's just copy in the code from our solution method here all the way up to answer. And so if we go into our Codility app here, we can copy it into here. Perfect. And if we run the test, everything should be working as intended. Oh, no. Oh, right. We also have to copy in our imports here at the top. So let's do that real quick. And we can run the test and everything compiles successfully. So perfect. So yeah, we had to copy in the imports so that the program knows which directories it has to use. So from there, everything should work as planned. So if we just submit the task here, we should get a grading from Codility and we'll see how our code performs. Okay, so let's let this load for a little bit. Shouldn't take too long. So the score will be shown once evaluated. The submission is being evaluated here at the bottom. Perfect. So we got a total score of 100%. So that's what we like to see. And on this question, it also tells us that we have a detected time complexity of ON, or ON log n. So that's awesome. Perfect. So with that, that's going to be the end of this tutorial. As always, leave a like, leave a comment down below if you have any suggestions on content you'd like to see. And yeah, see you guys next time for the next tutorial.